You look at the river gently flowing by. You notice the leaves rustling with the wind. You hear the birds, you hear the tree frogs. In the distance you hear a cow. It's quiet, it's peaceful. And all of a sudden, it's like taking a deep breath and going, oh yeah, I forgot about this.
30 million metric tons of carbon dioxide are emitted globally each year. 8.7 million metric tons come from the burning of fossil fuels. Current trends are moving towards even more carbon-intensive sources of energy, such as the oil sands. Last year's emissions from waves, 0 metric tons. Welcome to the Wave Dragon, the world's first floating slack-moored energy converter. The images you see here from the first prototype, deployed in Nissan Brending, Denmark. Long-term testing is being carried out here to peak performance and test power production in different sea states. The rig is based on elevating water to a reservoir, then laying it out through turbines which convert that potential energy to electrical power. Waves are focused onto the ramps in a process called overtopping. Next, the water is collected and stored in a reservoir. In the current prototype, this capacity is 55 meters cubed of water. The last step is power takeoff, where water flows down through hydro turbines to produce power. The only moving parts in the rig are turbines, which greatly reduce maintenance as well as output loss due to breakdowns. At the same time, much time and effort has been put into maximizing the design to produce the most energy at the lowest cost in an environmentally friendly way. The Wave Dragon is moored, like a ship, optimally in 40 plus meters of water. Also, further offshore placement allows for wave power to be taken advantage of before it is weakened by the shoreline. What about stormy weather? The Wave Dragon is constructed with air chambers that can be inflated or deflated to adjust the height of the rig in the water. In high winds, the rig can be lowered almost to sea level, minimizing risk. Wave Dragon uses hydro turbines that have been tried and tested in over 80 years of field use. This ensures reliability of the rig, yet at the same time, even more productive turbines are being researched. The rig consists of 2 reflectors focusing waves towards a ramp with a reservoir behind. The ramp is made from either steel or reinforced concrete with 2 wave reflectors made of the same material aimed at concentrating the waves onto the ramps. The mooring system is designed not only to hold the rig in place, but also decrease the effect of the force of the waves on damaging the structural integrity. The water collected is used to turn turbines which work with permanent magnet generators to produce electricity.
The physics behind the Wave Dragon are rather simple. The concept is very similar to that of a traditional hydroelectric power station. There are 2 reservoirs, one being elevated above the other, and electrical energy is produced by utilizing the flow of water between the 2 reservoirs. The amount of potential energy in the system is defined as E equals mg delta H. To take this potential gravitational energy and convert it to usable electrical energy, water is allowed to flow from the higher reservoir to the lower one, which converts the potential energy into kinetic energy. The flowing water is then used to turn a turbine. A permanent magnet generator then converts this kinetic energy into electrical energy. Beyond the simple physics of the concept, there is also some very advanced physics, working in the details of the project. Many calculations and computer models were done to determine the oval shape was the ideal one for the wave reflectors. This shape was proven most effective at harnessing the maximum amount of wave energy. Similar strategies were done to determine the ideal shape of the ramp. There is even more advanced physics and engineering that is going into designing the turbines that will be most effective at extracting energy from the water. Current turbines have been designed to use in high quantity and high velocity water flows, seen in hydroelectric dams. Modifications must be made to adapt these turbines to the lower flow.
The manufacturers of Wave Dragon are continuously improving and running tests on the prototype in hope of one day being able to produce a large fleet. They are currently on the way to producing a 7 megawatt rig in the North Sea. This table shows comparisons between the current prototype and the potentially scaled up rigs. As you can clearly see from the large improvements in energy output, this technology is viable as one that could eventually reduce the dependency on fossil fuels.
The map shown here displays the wave strength in different coastal areas. Considering the fact that the current prototype, producing 20 kilowatt, in 0.4 kilowatt per meter waves. The potential of this device can clearly be seen when looking at coastal regions with 30 plus kilowatt per meter waves.
From an investor's viewpoint, a transaction is viable if and only if it can be profitable. This does not hinder the Wave Dragon, as with its high potential levels of production, it could easily power entire coastal areas. Also, since it uses standard parts in its production and uses simple and durable design, manufacturing and operation costs are minimized. All these factors also help to make the rig more competitive with current dirty sources of energy, which is a huge factor in reducing global emissions.
With technological developments like the Wave Dragon, our dependency on fossil fuels will have the potential to decline. The reduction in carbon emissions this would bring would lead to cleaner air in our cities and help mitigate anthropogenic climate change.